Integration of paradigms for rotational grazing systems on U.S. rangelands. At the turn of the 20th century, overstocking and ill-timed grazing led to extreme vegetative defoliation, resulting in decreased soil stability and hydrologic function. Specific grazing was developed to address these problems. Deferred rotation grazing delays grazing until seed set. It was studied in northeastern Oregon by Arthur Sampson and applied rapidly to rangelands across the nation. Later, rest rotation grazing was developed by Gus Hormey in northeastern California and was also widely implemented. This grazing system involves resting a pasture for an entire year. These grazing systems were not employed as a result of strong scientific rationale, but rather existing social, environmental, and economic pressures. Despite the lack of scientific support, these grazing systems have helped to stabilize many rangelands degraded by overgrazing, but changes in species composition and invasive plant establishment have also been attributed to their implementation. Today, these negative legacies, along with litigation and economic changes, have prompted many private and public land managers to consider alternative approaches to grazing management. To find solutions to these problems, managers can look at systems used outside of the United States. Many African cultures use a flexible and actively managed grazing system on communal lands. This pastoral grazing system often involves one small mixed animal herd per family. Members of the family herd the livestock to fresh pastures as needed. Some of the beneficial impacts of pastoralism include utilization of more vegetation types with multiple classes of livestock, improved animal management with constant human presence, and a very flexible system of management. Main constraints to large herd size include a limited ability to invest in land and water development, as well as veterinary technologies. There are benefits and drawbacks to pastoral grazing, but the beneficial aspects of pastoralism can be integrated with U.S. grazing systems to alleviate some of the current problems. In the late 1900s, time-controlled grazing, otherwise known as short-duration, high-intensity grazing, was conceived in Zimbabwe by Alan Savory. Incorporating aspects of time-controlled and pastoral grazing with aspects of U.S. rotational grazing systems will unite pastures and herds into a large-scale collaborative operation. This provides more resources and greater flexibility for enhancing rangeland health and livestock production. The Rich County Allotment Consolidation Project in northeastern Utah is used as a case study to illustrate such an alternative approach to grazing management. If successful, similar management systems could be incorporated on other North American rangelands. It is important to consider that a new grazing system by itself will not solve the current problems in the U.S. grazing system. Rather, a high level of management is key to improving rangeland health. It has been stated that management commitment and ability are the most pivotal components of grazing system effectiveness, and grazing systems do not possess unique properties that enable them to compensate for ineffective management. When properly managed, livestock grazing can be one of the most effective landscape scale tools for enhancing rangeland diversity and productivity. The current situation in Rich County, Utah is forcing private and public land managers to rethink their approach to grazing management. Undesirable vegetation change, water quality issues, pressure from special interest groups, and rising costs recently led 11 stakeholders to form the Rich County Allotment Consolidation Project, which should be operational in 2012. This collaborative effort integrates federal, state, and private lands into a 143,000-acre grazing area with 26 pastures. Pastoral aspects of multi-species grazing of cattle and sheep and communal use of rangelands with 29 permit holders are combined with beneficial aspects of time-controlled rotation that incorporates deferment and rest. Permit holders will employ riders for daily management of animals and monitor rangelands for adaptive management. Additional water development and fencing will be necessary, but the benefits of operating on a larger scale outweigh the drawbacks and facilitate the restoration of rangeland health. By implementing this project, managers hope to increase available forage and browse, increase biodiversity, improve water quality, and increase management flexibility. This project is validated by a similar ongoing effort at Deseret Land and Livestock, a nearby 200,000-acre ranch which has achieved dramatic rangeland health improvements and increases in livestock production and biodiversity since 1981. During the last 30 years, they have almost doubled the number of cattle and elk that can be sustained on their land, increased by 4 times the number of moose, and have 5 times the number of sage-grouse. In conclusion, deferred and rest-rotation grazing systems have stabilized degraded rangelands, but have also left negative legacies such as undesirable vegetation changes. Adding to the difficulty of the current situation, policies, litigation, and rising costs place constraints on individual producers, making it difficult to implement alternative approaches to grazing management. The consolidation of allotments into a larger collaborative operation, where more flexible and active management is expected, should improve rangeland health and livestock production. This integration of international paradigms and practices of rotational and pastoral grazing systems has the potential to alleviate many of the current constraints influencing grazing management on U.S. rangelands today.